If your vision system is missing defects, the first thing most people do is upgrade the AI model. And almost always that's the wrong fix. In this video, I'm going to tell you where to look first before you touch the software. I'm Raghava, founder of Qualitas Technologies. We've deployed over 200 vision solutions globally. When a vision system underperforms, there's a natural instinct to look at the software, to retrain the model, adjust the thresholds, try a different algorithm, maybe a filter, and sometimes that's right. But more often than not, the problem was created before the software ever got involved. Because here's the reality. Software works on the image, and if the image doesn't contain the information you need, no software can recover it. You cannot find a signal that isn't there. Think about what happens before the software ever sees a frame. Light hits the part's surface reflects the light in some direction, towards the camera or away from it. The lens gathers that light and focuses it onto the sensor, and the sensor converts it into a digital image. Only then does the software get involved. Every one of those steps either captures the defect signal or loses it. If the lighting geometry means the defect creates no contrast, if a scratch on a shiny surface reflects light in exactly the wrong direction, the defect isn't in the image. The software sees flat data where the defect should be. That is why software is downstream of physics. Fix the physics first, then look at the software. In my experience, the most common hardware problem that gets misdiagnosed as software problems are these three. First, lighting that has changed since the system was installed. LED lights degrade. Their output drops gradually over months, and the change is invisible to the eye but significant to a camera. A system that was well lit at installation may be measurably dimmer a year later. Second, ambient light interference. This is especially common in plants where lighting environments change between shifts. Daylight through skylights or windows, different overhead lights being on or off. The camera was configured in one lighting environment and is now operating in another. And third, lens performance at production conditions. Now this may not seem very obvious, but a lens that was adequate during a pilot may show distortion or focus problems at the edges of the field of view when running full production speeds with real part variation. These show up as inconsistent detection at the edges of the frame, a pattern that looks like a software problem but is caused by the optics. Before you escalate a performance problem to your software vendor, do one thing. Save 10 images of a known defect. Parts you've confirmed are bad. Open them on a screen and look at them yourself. Can you clearly see the defect in the image? If you can see it without difficulty, the hardware is doing its job and the problem is likely in the software or its configuration. If you struggle to see it, if the defect blends into the background or you have to look hard to find it, that's a hardware problem. The software cannot do better than the image it allows. Go back to the hardware first. This one takes 15 minutes and will tell you which direction to go before you spend weeks retraining a model that isn't a problem. We've put together an Image Acquisition Toolkit, 6 free tools that help you diagnose and spec your imaging hardware before you touch the software. Let us know in the comment below whether you like a free copy and we'll send it across to you.